And today's webinar will be talking about, actually more than just talking about, we'll actually be showing you how to work fast in SolidCAM 2000, SolidCAM, in this particular SolidCAM 2015. And we'll be using such tools such as our templates, iMachining 3D, HSM, Toolbox, all sorts of options that we have inside of SolidCAM to help you work a lot quicker. So actually it's going to be more of a learning experience, showing you all these tools that we have that can actually make your programming go a lot quicker. So what I'm going to be doing in this webinar is we'll actually be programming some parts, and we'll be using these tools to help us work a lot quicker in the program itself. So let's actually get started now. And what we're going to do right now is we're going to first start with this simple part. Now what I'd like to do in this part is very simple. I'd like to actually machine the part. Okay? Well, let me see now. What we have in here is we have, I'd like to do a face mill operation on the part, and I like to profile it around, mill out these corners over here. My stock at this particular point, if I were to open up my stock definition over here, on the outside it's actually the exact measurements of the part itself, and we just have an excess of 1 millimeter on the top of the part itself. Okay, so let's actually start machining the part. Now, I'm going to point out some, as we go along, as I program the part, I'm going to actually point out some of the features that I'll be looking at in particular. So first, let's actually start with, like I said, with a face mill operation. Okay, we'll click on face. As you see, we have our 2.5D toolbar over here. By the way, if you weren't in my webinar last week, this is SolidCAM 2015 Service Pack 3, which is coming out within the next week, and we will have new toolbars over here, such as a 2.5D toolbar, and we have a face operation directly over here. So I just click on face. Note, the moment I clicked on face, I am working already in a template. So I have everything I need. I have my technology is all defined already, and my tool is already defined in this particular case. All I need when I'm working with templates, okay, once I set up exactly the way I want it, it's just to create my geometry and just check my levels. So let's just go and create my geometry. I'll define it according to my target. And all I have to do now is save and calculate. And my operation is done. Let me just go through the operation to show what's exactly inside of here. Is that my template was set with a 50 millimeter face mill. My levels was set at 0, and my technology was set with a spiral toolpath around into the part itself, which is exactly what I got. And that's all I needed to do to program this part. I used templates. Now templates can be made exactly the way you want to work. Now, just because I use a template doesn't mean I'm locked that I have to use everything that way. I can make changes. This is just a regular operation, just like anything else. I can make any changes I want, and I can even resave that template under the same name to update that particular technology or tool, or make a new template. But we'll go into that a little further on down the road. Okay, so I created my first operation, a face mill. You saw how quickly I was able to do that. Okay, next, I'd like to create a profile operation. Okay, so let's get rid of the check mark over here, and I'm going to create a profile operation. And note, it's also coming in with a template. Okay? Where these templates are coming in from, I'll show you in a moment. I'm just going to choose my geometry. And in this particular case, I'm just going to choose the outside boundary over there. My tool is already defined. My levels. Note, because I picked my geometry from the bottom, my profile depth is automatically put in there as well. And I have the technology that I'll be working with in this particular part. Rough cut, finish cut, everything else is set over here. All I have to do is do save and calculate. And you saw how quickly I was able to do that. Note, you can see that exactly on my tool path as well, around the part. Now, let's take a time out for a moment, and let's see exactly where these templates are actually coming from. Okay. If I were to go into my SolidCAM settings, so go to SolidCAM part, and we have here CAM settings. Whenever I start a new project, the new project always starts according to the way these CAM settings are set up as. So if I were to go to my templates, you'll note that I have a template for each of these types of operations. Therefore, every time I start a new project, these templates will automatically be marked off to start off in my operations. Okay. Now, besides that, if I go into my CAM part settings, my actual part on an individual level, we also have our templates here. You'll note that they're all marked. Okay, they're all checked off. Therefore, they're all coming in with a template already in there. If for some reason I don't want to work with templates, in this particular case, or switch a template, I can go in here and switch to a different template if I had more than one, or I can turn them off and they don't have to work with the templates. Let's leave it all set for now, and we'll just continue on. Actually, you know what? Let me take them off as if I'm not working with any templates at all. Okay, but you saw how quickly I was able to create the operations using templates. Okay, now what I'd like to do, let's start actually doing a pocket operation in here. Okay, so if I go into Pocket, you'll note that this time it came up with no template in here. That doesn't mean I can't use a template. I can always go over here and open my template list. Note that it'll only show me templates that I've built for that particular type of operation. For instance, a pocket operation, so it's showing me only the templates for the pocket operation. Okay? So in this particular case, I'd like to work, say, with a pocket template that I created that has 6mm end mill. Okay? All I need to do now is create my geometry, and I'm going to create my geometry. Let's choose this edge over here. We'll do curve propagation. Note, my levels are automatically down to the bottom. We have our technology. Everything is set according to the way I want to work in this particular case, including my links. Let's do save and calculate. And as you can see, my operation was created. I didn't do anything. All I did was I loaded my template. Now, if I want to make changes in the template, no problem. I can go into any one of these, make any changes I want, save it again, and I'll have another template. Okay? Let's leave the templates alone for now. And let's actually start concentrating on other options besides templates. Now, what I'd like to do is I'd like to actually mill out this corner over here. We have this corner, which is these walls over here, as well as this one going around at the bottom over there. So two separate corners in here, up until there, and then at the bottom to there. So let's try doing this first with your typical profile operation. Okay, now remember, I'd also like to do this on all four sides over here. So we're going to start, let's start by doing it with a profile operation. And let's see how much work I have to do in order to actually do this without any kind of templates or any other kind of tools. A simple profile operation. We'll go into profile. Okay. Create a geometry. My geometry is going to be these three edges over there. That's my geometry. Just want to work in that corner. Okay? And you know what? I'm going to, in any case, load a template. Let's load a template that has this profile with a tangent approach over there. Okay. Note, I have my tools there already. My levels is already set at the very bottom. If I'm not sure, I can always go here and just click at the bottom edge over there. Let me actually catch the corner. Actually, I don't want that. I want this surface over here, because this is around. This is going around here, so I'm only going up to that surface. Okay, so 12 millimeters. Top is over here. My technology, I have a rough cut, finish, everything's fine. You can see my link is set at tangent, because that's the particular template I took. So I really didn't do much here. Let's actually run my simulation now. And I'm going to run it, and as you can see, actually, let me stop for a moment. I want to get rid of that profile operation I did before, so I'm going to delete that. Okay, now let's run this operation. Let's run the simulate on that. Note, it's going down and milling out exactly what I told it to do. But we still have to clear out all of this material over here. So going back to the profile operation, well, I can do that, not a problem. If I go into Vector Technology, we have our clear offset. But note how much work I'm doing in order to get this done. I go to my clear offset. Now I have to figure out what's the distance of the clear offset. Well, let me measure the distance between this point here and that point here, and I see that in my X and Y direction is both 80, so I'll put in a value here of 80, say less 5 millimeters, I'll put 75 millimeters, with a step over of every 5 millimeters. Let's see what the result is in this particular case. Let's get rid of the toolpath so we don't have to see it right away, and we'll see the following. You see it's actually doing exactly what I wanted it to do. Okay? Clears out that entire step. But you saw how much work I had to do in order to clear out that material. Well, for that, we have special tools. Let's see what kind of tool I have, what kind of operations I have, specifically for shapes. Okay? What I mean for shapes, I mean for typical corners and slots, as shown over there, O-ring operations. What we have here is something called Toolbox cycles. Toolbox cycles is specifically designed as if it were a canned operation for specific shapes. For example, this is a corner. I want to mill out the corner. So let's go now into my into my, here we go, Toolbox cycle. If I have to go into my Toolbox cycle, I can open up my technology box, and you can see we have a whole set of all different types of shapes. Now what I'd like to do is the simple corner. That's all I want to do. Now you'll see how easy it is for me to actually program it using the simple corner. But before I do that, let me go out of here and get rid of this operation that I created over here. I'll delete that one. And now we're going to start my Toolbox cycle, and I'll use, as I said, the option of simple corner. All I have to do in the simple corner is just pick out that one edge, the outside edge. One goes from here into this, that leaves this area over here. That's all my geometry has to be. Let's take a look at exactly what I'm talking about. 1, 2, 3. That's it. That's my geometry. Okay? The tool, I'm going to use a 10 millimeter end mill. Okay? So I created the geometry, my end mill, my levels. My level is going to go down to that step over there, and my upper level is over here. In my technology, note there is no clear offset. Nothing has to be done. All I have to do is tell it what's the step that I want to do. Say every 5 millimeters. The step over is automatically put into here, and I can work one way or zigzag, just leaving it exactly the way it is let's see what happens. Okay? By the way, we also have passes or slices. Let's just do save and calculate and simulate. Get rid of the tool pass over here. And you'll see in this one operation, it's doing exactly what I did before in that one operation. But this time, I had a lot less to deal with. I didn't have to say what my clear offset was to start figuring everything out. I didn't have to deal with what my lead in and lead out was. Everything was done in one simple operation going across. Now, note it went down exactly to its step. And it's also cutting very efficiently. If I take the top of the look, you see it's only cutting in the areas where there's material to be taken off, in this area over here. Not doing any excess cuts on the outside over there. Now, one more thing I did not do yet is, remember I said that we have to do this in all four corners. Okay? Now, besides this corner that I did here, I also want to do this bottom corner. So first, let's take the issue of the all four corners. Well, inside the operation, we have a transform. I can go directly to transform and say, you know what? Let's take the operation and we'll rotate it, include the original one. We'll rotate it 90 degrees 3 times. We'll add that. Now, if I do, you can see that it was done all 4 times, on all 4 corners. Now, since I do want to do the other one at the bottom over there, and that's also going to need a transform, I'm just going to do something very simple now. The idea is to program as quickly as possible. I'm just going to do save and copy, so I have a new operation already with all the parameters that I had before, including the revolve around the part to do my transform. All I have to do is create a new geometry. So we'll go and create a new geometry. This time it's here, here, and here. We'll accept that. And the only thing I want to do now is just check my levels. My upper level in this particular case is over here because I already milled down up until that level. My depth is already 8 millimeters. Note, it says 8 automatically. That's because I took my geometry from the bottom. But just to make sure, I always like to click on the corner over there, and you see it actually is 8 millimeters. All I need to do now, save and calculate. Note, it automatically did it for that area as well. As we can see in the simulation, you can see that that's all 4 corners. I don't have to do the transform again. And it clears out those operations over there. Okay? So all 4 of those are all 4 corners as well as both steps over there. So using the toolbox helped us out immensely in this particular case. Okay. Now, let's continue on down now. And what I'd like to do next is to machine out these areas over here. Now, this is an area for an O-ring. Okay? You can see that's equally spaced all around. Okay? The slot is equally spaced all around. And again, I also have this on this side as well as that side, so it's a rotate of 180 degrees. So we know that already, excuse me. So let's first see how I would normally do this in your typical operation without using the help of toolbox cycles. Well, let me see. First of all, the distance between this wall and this wall over there is 4 millimeters. So I'm going to use a 3 millimeter end mill for this. Now, the way I would like to machine this, okay, is I first like to go down the middle, smack middle inside this particular O-ring, and even in a helical descent into the part itself. And after I finish that, then I'd like to do an operation where I can just clear off the walls with that same tool. Okay, so let's first try doing it with a profile operation. I'll go to profile. Okay, I'm going to create my geometry. First, I'd like to go down the middle. So in order to do that, since I don't have a geometry in the middle, I'm going to take a geometry that I'm going to create on the side and do an offset to it. Let's see how I can do that simply by clicking on Create Geometry. That's obviously the first thing I have to do. And I'll click at the bottom edge to get my depth at the same time, and curve propagation to create my geometry. Okay. Next, I'll choose my tool. I'm going to choose my 3mm end mill that I have over here. My levels, they're all set from 0 to 3. Now let's go to my technology. I'll put this in my top view. Now, right now, I'm working smack against this, but I want to take my geometry that I had over there and put it exactly in the middle, and I want my tool to work on the center of that geometry. So first, I put it on center. Now I'll go to Modify Geometry. Okay? And since I want to move the geometry halfway across to this edge over here, we have the option of Modify Offset, of take half of the selected offset, and I'm selecting this as my offset, so I'll go half the distance. Okay? And I said I want to actually do a descent in a helical fashion. So what I'm going to do is use depth type, not constant, but helical. And in my step down, I'm going to have it go down every single time it goes around the part. It's going to go down another 0.5 millimeter. In my links, I'm just going to leave that at none, and that's it. Let's see what's going to happen now. Save and calculate, simulate, and as you see, it's doing exactly what I wanted it to do. Going down the middle. Okay, perfect. But you saw how much work I needed to do in order to do that. But wait, I'm not finished. I still want to do the edges. Okay, so I'm going to do save and copy, create a new operation. Let's get rid of that toolpath. And I'm going to use a new geometry this time. This time, my new geometry is going to be, again, this edge over here, curve propagation, as well as this edge over here. Pay attention also to your direction, curve propagation. Okay, the tool I already have in here. Levels, they're already set. Now, in my technology, instead of working center, because I want to finish the walls now, I'm going to work left. And my depth type, instead of helical, I'm going to have it as constant. Now I'm doing a finish cut, so let's step down. I'm going to leave it step down at every 0.5 millimeter. Okay. And we need our lead in and lead out. Well, my lead in and lead out, I have to start to do a little bit of a in my head calculation. So let's see. This is 3 millimeters off over here. So that means I have a 0.5 millimeter left on each side. So I'm going to walk away using this tool. I'm going to use a lead in of an arc of a 0.5 millimeter, 0.5 millimeters, and the same for my lead out. Okay, let's see exactly what happens here. And you can see the tool is going to go down, arcs in. You can see it's actually doing exactly what I wanted it to do. Now, you saw how much work I needed to do in order to create the operations to do this. Let me get rid of this now, what I just did, and let's do it quicker. How can we do that quicker? Simply by using a toolbox cycle. We choose toolbox cycle, and this time we're going to use the option of O-ring. Okay? I'll click on O-ring, which is exactly what this is. All I need to do is choose my geometry. So my geometry is going to be that edge over there, as well as this edge over here. Let me zoom in a little. this edge over here. Constant. Now note the direction does not make a difference. Okay, I can have them both go in the same direction. Doesn't make a difference. The tool, I'm going to use the exact same tool, that 3mm end mill. Levels 0 to 3, that's fine. My technology, note, all of this is being done in one operation. My step down, I'm going to have my step down at every 0.5 millimeter. For my rough cut, my rough cut is going down the middle. And I want to also do a wall finish. And I'm going to leave it exactly the way it is. Note, there's no lead in, lead out to take care of. That's all I did. One operation. Don't forget, we still have the option also of transform, rotate. Let's do list, include the original of 180 degrees. Let's see what the result is. Take a look at our simulation. Okay. First of all, you can already see the tool path that's first going down the middle and then clearing off the sides over there, and it's doing it on both sides. Let's actually see this in the simulation itself. I'll do this one step at a time. You can see, I'm going to try and zoom in over here. You can see that my tool is actually going in with a helical descent into the part itself, exactly in the middle. Now, once it gets to the bottom, it'll automatically clear those walls and then go over to the next side. Okay? Note, all this was done in one simple operation. Instead of what I had to do last time, 2 different operations, modify geometry, there was a lot of work involved. Okay? Now, if I'm already doing these kind of the toolbox cycles, you know, let's continue to do a couple of more, and then we'll go to our next part. For example, I'd like to let's machine out this area over here. Okay, I'm going to machine out this slot going across over there, and then afterwards I'm going to do these closed slots over here. So again, let's do our toolbox cycle. This time for this open slot on both ends, I'm going to use the option of roll in to open slot. Now, the reason why I'm using roll into is that the tool that I'll be using will be a tool that has inserts in it instead of a regular end mill. So with inserts, it's always better to roll into the material. So we have one specifically for that. Choose my geometry. Note, I'm picking this first edge over there. And then I'm going to pick the second edge over here. Okay, this is contour number 14. Remember that? My tool is going to be a 20mm end mill. Depth down to the bottom over here, 5mm. And my technology, it just has my step down. I'm going to leave my step down exactly the way it is, and everything exactly the way it is. No changes over there at all. Let's run my simulation. Note, you can see the tool path itself is actually rolling in. Let's do the actual simulation. Let's take a look at the actual top view of the part. You'll see that the tool rolls into the material and cuts across. Okay? Once it's done, it picks up. That's all I need to do. Now I still want to clear off the walls. So for that, we have another operation, and I'm going to do, instead of roll into open slot, which is just down the middle, I'm just going to do a regular simple slot as shown over there. Same tool, same geometry, same levels. My technology, I'm just going to do a plain old finish cut. Run my simulation. Look how quickly I did that. One side goes over to the next side, and it's all cleared up. Now, about those slots in there, well, we also have a technology for that. Toolbox cycles. We have a cycle for that, which is called as you can see over here, according to the picture, closed slot. Okay, now this particular slot is a 6 millimeter slot. So I'm going to use a 6 millimeter tool. This is particularly in the cases where I'm using the tool that's the exact same diameter. The diameter is exactly the width of the slot itself. I'm going to choose the geometry. Let's choose that curve propagation. Let's do the second one over here as well. Okay. Of course, if I want, I can do this as transform and copy, but I'm just going to do it this way right now. Okay. Curve propagation. And the last one over there as well. The tool, like I said, is going to be a 6 millimeter end mill. So I'm going to use my 6 millimeter end mill that I have over there. And where are we? Yes. And we have our levels. My upper level is over here. That's my top. And the bottom is down to the bottom over there. Of course, I can give a delta if I want to go a little past. And my technology, all I need is my step down. Let's go step down of every 3 millimeters. Let's see exactly what happens now. If I run my simulation, what you'll see is as follows. The tool is actually going down in a zigzag fashion into the material itself until it gets to the bottom. Okay? And it does it for all of these slots over here. Now, just to take a quick look, we also have technology cycles for we have one for broaching. We have for roll into closed slots, wide slots as a additional zigzag slot, which is these wide slots. We're using a tool with a that is less than the actual diameter, the actual width of the slot itself. We have what they call rib machining for thin walls. All of these are inside our cycles here. Now, what I'd like to do is actually choose a different part. Okay? I'm going to start now with a different part. Okay. Now, the part I'm going to use looks like this. Okay. This part now is a little different. This part, as you can see, has many different pockets, different depths to it, all over the place. Okay? So the first thing that comes into my head as far as machining this quickly, well, the first thing I want to do is actually just a face mill. Okay. Face mill, I'll go into my face mill operation. This time I don't have a template here, but I can always load my template. Okay, I have my templates turned off over here, but I can always use them. Choose my geometry. I'm going to use it around my stock. My stock in this particular case, as you see over here, is like this. Okay. You can see my levels, everything is set at 0. Quick save and calculate. Run my simulation. Let's do it a little slow over here, and you can see that it actually machines around the part itself. Okay. We'll get rid of that. And let me just get rid of the actual stock and just let you see the actual part itself. Now, I have to start working in all these pockets. Well, I'm going to say to myself, you know what? Let's use the most efficient way to remove all of that rough material. And the quickest way to do that is by using iMachining 3D. It's exactly what I'm going to do now. Okay? So we have iMachining 3D. I'm going to use for prismatic parts. Okay? Note, at this point right now, I'm working all of the time in my SolidCAM 2.5D toolbar on top over here. Okay, so we have iMachining 3D. You may ask why I have this inside my 2.5D toolbar. because since I'm working on prismatic parts a lot of times, even though I'm working 2.5D, I may want to use this pretty often, which is what I'm doing right now. Okay, so I'm using the iMachining 3D. We'll use the 3D prismatic. Note something interesting. Note I'm using a template. This template automatically gave me the tool I wanted. Okay, I wanted to work with a specific tool, and I'm working with a 12mm end mill. It doesn't mean I can't go in here and make any changes, but it's coming in here with the tool already, exactly the one I had. In this particular case, exactly what I want to work with. Okay, my levels are all set. My technology wizard is all set. There's nothing really I have to do here. Maybe my wall offset, I'm going to change that to 0.3 millimeters. Okay, but other than that, nothing else has to be done. I'm just going to do save and calculate. Now, I happen to know that in this part, the 12mm end mill, okay, is a large part. I want to use the 12mm end mill. However, the 12mm end mill cannot go into every single area. There are areas that it will not machine because the tool is too large to go through these areas over there, clear out certain pockets over there. If we take a look at the actual simulation itself, you'll see, all right, it did the outside, but as you can see, let me go a little quicker. You can see that it's machining around very efficiently, in fact, but there are areas where it could not go into, such as this area over there. Okay, there are certain areas where the tool cannot go through, so it didn't machine, couldn't go, hadn't have room to actually spin down into there as well, so it skipped those areas. So for that, all I have to do now, but you saw how quickly I programmed it. All I have to do now, save and copy. And I'm just going to use a smaller end mill. Choose a different end mill. I'm going to use a 6mm end mill in this case. Select. And that's it. Save and calculate. That's all I need to do. Because it automatically also, remember, iMachining 3D automatically also recognizes where there's material to be cut. It recognizes the fact that material has been taken away from certain areas, and in those areas, it will not machine anymore. So you won't have any kind of wasted cuts. It knows exactly where to cut and where not to cut. Okay? It knows where there's material and where there's no material left over. We'll take a look at our simulation as soon as it finishes the calculation. Okay, just a moment. And first of all, even before I do the simulation, you'll note already from the preview of the tool paths that I have over here. Okay, you can see it's only machining in areas where that particular tool, the 12mm tool end mill, cannot cut before. Let's go back in here and run our simulation. And you'll see it's only going to machine in those areas where it needs to machine. Okay? Extremely efficient. Programming is extremely quick in this particular case. Okay? Very little I had to do here. Everything was all set for me. Okay. Now, next, what about finish? Well, I'm going to do finish by using HSM. Okay? Now, in HSM, I have one particular operation, one type of technology that I like using over there, specifically for prismatic parts. It's an operation that includes constant Z and horizontal areas, such as floors. I'm going to go into my 3D operations and use HSM. And I'm going to use the option of combine constant Z with horizontal machining. Now, remember, every single operation, by the way, I can make a template if I want to. I'm mentioning that over here. In a few moments, you'll see why. Okay, the tool I want to use in this particular case, I'm going to use a 10mm end mill. Okay? My constraint boundaries, I'm going to have it go external so I can also machine the outside as well, finish out the outside. Excuse me. And my step down, I'm going to go down every 5mm. Now, besides that, I'm going to use something, an adapter step down, so to clean any other steps that's in between as well. Okay? Go down on the wall as far as it can, as close as possible to the floors. I'll do adapter step down. Automatically insert extra passes if there's more than 0.2mm left on the instep as well as the floor. Now, one more thing I'd also like to do. In my edit passes area, I want to make sure it's only cutting where there's material to be taken off. Okay, so I'm going to do edit using surfaces, and what surfaces to use? The automatic auto updated stock. And in this particular case, I'm just going to have an over thickness of 0. Now, by the way, again, if I want, I can save this as a template so I can always have it available, these settings, exactly the way it is right now. But let's continue on down now. Let's go to link. Sorry, back to constant Z passes. That's all fine. My link, I'm going to have my lead set at a basic horizontal approach. Now let's go to my horizontal. That's as far as the Z passes. My floor passes, I can have as follows. Leave everything the way it is. Just one note, detect core areas. In other words, wherever I can go in from the outside, that's how you're going to go onto that floor. Now, I'll do save and calculate. Let it do its course of calculation. Now, again, this is a 10mm end mill. There are certain areas where the 10mm end mill will not be able to work. Okay? We'll see that in a moment. Excuse me. Okay, you can see the tool path that was created up until now. But there's still areas where I know this tool was not able to go into. So I'm just going to do a simple save and copy. I'm just going to switch tools. I'm going to use now a 4mm end mill. And I'm not going to make any changes over here. The reason for that is because, remember, in my constant Z, in my edit passes, it's still looking for auto updated stock. So it's only going to work where there's material left over. Okay? Let's get rid of this toolpath for a second. We'll do a save and calculate. And you'll see it's only going to work in certain areas. Now again, this also I could have made a template. But in a moment I'm going to show you something a little cooler than just making a simple template. Okay? Now, you'll note that it only worked in specific areas where that other tool was not able to work. Now, let me go out of here. Now, I have these two operations over here that I created. You know what? Let's take these two operations, and instead of having later on, if this is something that I constantly go over, and these type of technology I want to use over and over again on different parts, well, instead of creating these two operations all the time, I can actually make what we call a process template. How do I create a process template? As you see, I marked these two. I chose these two operations. If I right-click on it, I can do Create Template. So what I'm actually doing is I'm creating a process template. Now, I've already created one before with the name I want to use in my previous webinar, but I'm just going to choose that name over there again. Now, since I'm overriding it, I can. And now I have a template that I want to use. Now, let me just delete these operations. And you saw what I had to do in order to create the operations over there. This time, I'm going to use that process template. Let's go into process template. I'm going to choose it. Click on OK. No changes needed. I have my two operations. All I have to do is select them both and just calculate them. That's the only thing I have to do. Calculate them. Since HSM, when it creates an operation, automatically puts the target in as its geometry, in this particular case, I didn't even have to go in and choose a geometry. Okay, they're both using the same geometry. Do save and calculate. That's all I need to do. And as you can see, it created the first one. Now it's creating the second operation. To finish off the areas where the previous tool was not able to work. And it's all done. You saw how quickly out of a process template I was able to do these two different operations. This is very helpful, especially when you're doing these types of operations where you'll always be using these types of tools. You'll need two different operations over here. And remember, these are regular operations. I can always go into them, make any changes I want. Okay? It's just an operation, just loaded with a tool, with a template. That's the only difference. But as far as an operation goes, it's your regular operation. Now, what better way to finish off this part? Well, I want to take off the sharp edges over here. Sharp edges, we have an extremely powerful tool for that, for deburring the parts. If I were to go into my SolidCAM 2.5D operations, we have here what we call chamfer recognition. Okay? Probably one of the most powerful 2.5D tools that we have today. Chamfer recognition, note, I already have it coming with a template with a specific tool. So I don't even have to choose a tool. My geometry, I'm just going to click on the part, and it's going to recognize the entire part, and every circle that's larger, every diameter that's larger than 10 millimeters, it's going to take that as well. Okay? Note, my tool is already here. My level is already, chamfer depth is already set at 0.5 millimeter. Don't forget, I can always make changes if I want. Technology, cutting diameter, links, everything is set exactly the way I want to have it done. Okay? All I need to do is save and calculate. Let's run my simulation. This time I'm going to run it using Solid Verify. This will take a moment because it has to, since I didn't do simulation with Solid Verify, so just updating the stock. This will take just a quick moment. And let me run this a little slow over here. And you can see it's actually removing all of the material exactly 0.5 millimeter on each one of these edges, all around. Okay? Probably the option of chamfer recognition is today one of the most powerful 2.5D tools that we have today. Very simple to use, but it takes so much out of the need to programming different levels for each one of these operations, for each one of these levels over here, all in one simple operation. The idea was to show you exactly how we can work quickly in different situations. So what we saw at the end was as follows. We saw how you can work with templates. We saw the use of toolboxes, toolbox cycles. We also saw the use of iMachining 3D, as we saw over here, as well as HSM for finishing off your prismatic parts. And of course, the option of chamfer recognition. All of these tools are just some of the tools that will help you make your programming time go a lot quicker. Okay, let me go through the questions. There are 2 questions here. The first one is, does O-ring cycles work only work with closed geometries? Yes, only right now it only works with closed geometries. Okay. Usually the O-ring is for sealing purposes, and it was designed specifically with intent for that intent. So the closed geometries is the way it has to work. Again, if you want to have anything specified, you can always use your regular operations. Okay. Another question I was asked, is there a reason to use curve propagation rather than auto constant Z? I've been starting to getting used to the option of curve propagation because that already includes constant Z. It includes constant Z in it, and it also includes in it tangent. So if I also have tangent in there, it takes it all. In those particular cases that I use, I could have used constant Z just as well. But I've gotten used to using the curve propagation, and that, like as I said, it includes already in it the constant Z. But you can use the constant Z. No problem over there as well. There's another question about the iMachining output details. Could we get that in the actual post? It's the output into the post itself, into the G code. I would imagine that's what you're talking about. You probably could. You probably have to do that. You have to speak to your local representative, as far as whoever deals with your post processor, to see if they can actually have your post output that information as well. Material, I'm not sure if it can, but I think it can. But then again, the best thing to do is ask your local customer service, who will actually, or your local support, and if it can be done, they can do that in your post itself. Okay, I'd like to thank everyone for joining the webinar, and hope you enjoyed it, and see you again next week in our next webinar. Have a great weekend, everyone. Take care.